horizontal strategy is how to overlap our vertical strategy in terms of first and second agency. So let's say that first one pick something like that for I1, and the second is this I2. So the overlapping is the horizontal strategy. So then yes, and it is costly to produce the news of quality Q. We remember that quality of agency I is a measure of choice of I, and they choose just the absolute value of I. And to produce quality QI, there is a cost function, which is, so we have some parameter C, and then QI squared. Yes, so, and then we are thinking about the aggregator. Yes, so we know that the quality of the aggregator is the union of E1 and E2. And then the quality of aggregator is measure of union of E1 and E2. So that's about agencies and aggregator. Any questions? No. Just brief reminder from the lecture.
I guess everything is clear.
So then we are moving to think about the agencies. So that's the uniformly distributed on interval 0, 1. And that's about the initial preferences between agency 1 and 2. So, and they can write down the utility of reading the agency 1, 2, or aggregator. So let's say we are reading the agency 1 with type X. So it will be some reserved utility for just reading something, and then quality of the chosen agency, and minus tau X, it's the transfer cost. Yeah, you remember that if we are some type X here, so that it's our X which we choose. So then the distance to the agency 1 is how we taste, how our taste to this agency better or worse for us. Yeah, so then we are choosing this distance, this is X, and then we need to multiply it by some parameter tau as a transfer cost to agency 1 as in our linear model. Yeah, if we will read the second agency, then we will have to multiply by tau 1 minus X if we choose to read the second. And then we can write the utility of reading the second agency and gain some utility of just reading something, then quality of the second agent, and then minus tau 1 minus X. Well, yeah.
Yeah. Sorry, I have a question. Um, maybe you've mentioned it already while I was fighting with this wonderful Yandex technology, but still. So, how could we interpret the transportation or just transport cost in this case? It's like the cost for me to switch to another agency, but
No,
it's
it's
not.
like how far your taste from the agency. Right,
Okay.
because we have a 0-1 interval, but then they need to have some ratio in utility, how it's really for us. Let's see, how it's really affect if we are far away or not, because it's can be important or not important in terms of utility. So that's kind of substitution between quality and distance. You see?
It's like my I know how to say it properly. It's like my resistance to the news, which I don't really like.
Not news, but the title of the magazine or whatever. So
Yeah,
maybe
okay.
yes, assume that you can read politics in only two journals in Maxim and in Komsomolskaya Pravda. So and maybe you don't like to walk on the street reading I don't know Komsomolskaya Pravda, for example, or maybe Maxim. So, but yeah, it's kind of weird example in terms of if they both produce news about politics. So then let's think about the aggregator. So the utility of reading aggregator is again so the utility of reading. So that's we can delete this part. Then we have measure of latitude 2. So that's the quality of the aggregator. And then we have these two parameters new1 and new2 because we have news from different agencies here. So this is share of agency 1, and this is share of agency 2 news on aggregator. Yes, because we still have these preferences between agencies, so that it's matter for us which exactly agency we will pick using the aggregator. Okay, is it understandable?
I have two questions.
Yes.
First of all, what is this U with it's like
U-bar?
yes, it's intrinsic utility from reading, right?
Yeah, it's like that you read something, but we can delete it from the analysis because you compare the utilities. And that's like if you will compare it with reading nothing, so then you have some utility from reading.
Yeah, okay. And the second one, share of first agency, share of the second agency inside the aggregate, right?
Right.
Okay.
Yeah, because you remember we have this probability 1/2 if the news are the same quality, and if the news are different quality, then they pick the best. So then, okay. And then we assume that the profit of the right agency on news aggregator is just connected to quality. So and then we will assume this profit functions. So that they have profit of agencies and aggregator, then they have share of the market, multiply by this. You remember they discussed that this was the time which agent spent on everything. So then minus CQI squared. Yeah, so they will assume that this will be the profit. So is share of the market. Yeah. So then let's start solving. So the first one, draw an example figure. Yeah.
Yeah, sorry. Before we start, as I can read in the task itself, so delta, delta sigma.
Which delta? You mean alpha?
No. Another parameter before q.
Yeah. Okay. Delta.
Yeah. Delta is a marginal revenue per quality. So we assume that higher quality goods are sold for more, right?
No. Like if you so that you receive profit only from the quality news. Firstly, right?
Yeah. Okay.
The
So
second, it's constant marginal. I mean, so that if you take the derivative with respect to Q, if you're talking about profit revenue, so then it will be constant. So that if you increase quality, you increase profit. That's the idea.
So for low quality, we don't have like any profit.
Yeah.
Okay.
So the low quality still gives you the share of the market, right? Because if you produce low quality on both agencies, so then you have share according to the according to the probability 1/2, right? On the
Yeah. Okay, got it.
so that you will have some share on the aggregator. So the first question is to draw an example of a figure showing how agency and aggregator cover topics. So that they need to take this interval 0, 1 and draw an example. So let me provide some example for you. I already draw one. So that if you're thinking about the first, let's say it takes from 0 to some point. So this is I1.
And
Yes.
And can we like assume a little bit more? I don't know how to say, interesting case in which the chosen quality is not like the how it is called in English. Well, just like two intervals, not one.
So you mean that I will take I1 like this?
Yeah.
Yeah, but that doesn't matter because you can reorder them, right? Because you don't have the distinguish between topic, let's say 1/2, and so then you can always put these together, right? So move it because you don't distinguish different topics, right?
But it will affect like the intersection of them.
Yes, but you will always have only 3 cases, right? So then you have some topics which are not. So let me show you. So that, yeah, if I will pick it like that, it will be the most general case because you have four different areas, right? So you have those topics which are not intersect, but doing with good quality by agency one. Then you have, right, the area there, the second agency doing good qualities and first not. And then you have both areas, then they intersect with good qualities and then they intersect with low quality.
Yeah, okay. Got the idea.
So that's the most general case, but then you can reorder them such that they are distinguished on the interval for different parts, so that, yeah, so then, and then let's draw what is presented on the aggregator. So then they have this is one, the quality of the aggregator, and they can see that this part comes from first aggregator, this part comes from second aggregator, when we have with probability 1/2 news from on these topics, and then we have with probability 1/2 news with low quality. So any questions here?
Yes, there is one question, but we don't exactly know what are the intervals, right? For the first and second agencies.
Yeah, we just provide some example.
Okay.
So now,
yeah. One question. So it's just the simplification of the model that we don't really distinguish between topics, right?
right. So you can just think about the measure of so that average number of covered topics. Not average, but absolute number of measures, so that's you can.
Yeah. I got it. Like this is possible because we don't really order them in any kind of quality. Like yeah, okay.
So then the second question is to write down the share of the news on aggregator. So in terms of quality, so okay, what is the share of the agency one then? The share of the news, yeah, we remember that entire interval it's 0, 1. So what is the share of the
What's the share of whom?
Of news from first agency on aggregator?
It's like 1/2 of intersection and the other part.
Right. So 1/2 of intersection. That's true. Then we have with probability 1/2 we have with probability 1 we have mu of I1
minus the intersection.
Yes, again intersection. Right, so this is this minus this. And then we have, with probability 1/2, we have the rest. So this will be 1 minus measure of union. Right?
Where did the last part come from?
So that's this part, right? So this is this part is 1 minus union, right? Because union is green one, so and then with probability 1/2.
But do we really have to consider this part? It will be the same for both agencies anyway.
Yes, but the total share of the agencies.
Yeah. Okay.
Of because it depends on profit. Yeah. So and we need to compare profit not only of agencies but aggregator as well. So yeah, and then this is share of the news. Share of the news of agency 1. No, actually not. It affects the utility of aggregator, and that affects the choice of consumers. Yeah. So, and now we can open it a bit more.
It affects the choice of the consumer through the choices of the aggregator, right?
Yeah.
Yeah. Okay.
So then I forgot how. So that's actually I guess you remember that if we consider the intersection of the so intersection is two unions, not two unions. Sorry, one union of 1, 2 minus. Yes, so if we will minus I1 and I2, then we will receive the same but with minus. So minus intersection is, yes, you can see. Is it obvious? So if you have set more I1, okay, I use different color now. So we have this is I1, and then we have I2 with some sets. The intersection, which is in between, right? So this is intersection. Then if we will take union, let me pick green color, right? And then subscribe from this I1 and I2, then we will double subscribe this intersection. So, and what will be in the rest is just one intersection with minus. Yes, so that we can use this formula to substitute intersection, right, with half of the. So if union minus intersection is union minus first and second. Yeah? No questions here?
Could you please explain it once again? And what does the minus mean in this case?
So that
It's like in Russian дополнение? No? I just got lost.
no, it's like okay, like it's better to write it in terms of mu, I guess.
Maybe you
Yeah.
could just explain like this thing again.
So then again, if you consider the two sets and you take the union of them, you receive just once all the area. But if you
Yes.
want to subscribe from them, if you want to get the intersection as a function of union and the sets, so you take intersection, then you minus first set. So you subscribe first set, subscribe second set. You will receive the subscription of the intersection twice, right? So that what will be left is the minus intersection.
Yeah, I get it.
It's not really correct to talk about the minuses here, right? It's
Yes, because we don't actually define like minus element of the set. So yeah, now I got your
here
idea.
should be. I'll tell you. Yeah, the correct formula is the following. So that one, I think it's. So if you take it twice, right, that will be intersection plus, not mu, right? But I'm not sure if the plus is correct here. Okay.
Yeah.
You get the idea. So
yes.
that's you can change it like that. So that now we can substitute here. Okay, let me pick another color. So then we can use it not here, that here. So then they can write that mu1 is what here will be 1/2 mu e1 plus 1/2 mu e2 minus 1/2 union mu of union and then plus here once again intersection. Okay. So here will be intersection, half of the intersection with minus, so we can change the sign here, right? So it will be plus, minus, and minus, and it will be plus mu1, and they already calculated for that intersection. What is the left is 1/2 and minus half of the union.
So we just using this formula for intersection, we like plug
to
it
put
in
it here and here.
like twice.
No, but once, because this is just minus 1/2, right?
Yeah, okay, got it. And
So
if it's minus,
so if you,
so we can actually discard minus as well, right?
yeah, that's why I just first I write it for 1/2 and then for minus half I change the sign for everything. So what we got is 1/2, and then we get rid of union, I guess, right? So that union is cancelled. And what is left is just 1/2 of difference between measure of 1 and measure of 2. So that's mu1. So then we can write mu2 analogically, so that will be, yeah. And that's the answer for shares of the news on aggregator. And you can see that the share depends only on their own choice of quality, not of some union of intersection, just their own choice of quality and difference between them. So any questions here?
I guess calculations are tricky but understandable. And as for the interpretation of the result, what should it be?
So that the share of the news depends only on difference of the quality between agencies, right? So that what is matter finally is the difference between quality. Yeah, because this is Q1, right? And this is Q2. And you can see that if you sum it, it will be 1, right? Just 1. So that total news divided between first and second agency, which is just to check yourself.
Yeah, okay.
So now we need to plug it in. So we need to put it into our U0 of x, which is, you remember the formula from setup. So then let's do it. So we can. So let's, for instance, forgot. So what we need to receive is we already have here the first part, right? So that this part is the same as in the answer. So we just will focus on that part. So that this part equals 2. So what we get there, so let's put tau out firstly. So we have minus, and then tau, and then what is inside is, so mu1 is 1/2 plus 1/2 mu I1 minus mu I2 multiplied by x, and then we have plus 1/2 so that's in brackets actually. Plus, right, plus 1/2, and then I will write it as a minus the same, because I can put the minus and then order I1 and I2 in the same way. And this multiplied by 1 minus x. Then we have tau, and let's open the brackets. So firstly, we will have 1/2 x plus 1/2 x, and I will just let me denote it with letter A. Okay, so just for simplicity, so that here will be A. So then I have 1/2 minus 1/2 x. Yes, and then I have minus 1 minus x. So yeah, 1 minus x A. So then I can cross 1/2 x here and here. That's gone. I just left with 1/2 here in the middle, so I will put it out, and I already received part of the answer. This is tau over half, right? And then I have minus tau, and what is inside? So what is inside is everything with A. So I will put A out, and what is left is, yeah, I forgot 1/2 here. That's important. So 1/2 A I can take out. And then I left with x minus 1 plus x. So I got tau over half, so over 2. When I got, yeah, to receive the answer, I need to change the sign, right? So that I have tau, and then I have here 1/2, but I want to put it inside, so because I will have 2 x's here. So then I will have 1/2 minus x, and then I will have A, and A is mu I1 minus mu I2. Yeah, and then just to receive exact answer, I need to change the sign inside the brackets once again. So that will be x minus 1/2. And then over here will be measure of I2 minus measure of I1. Okay, and then they receive the answer. Questions?
Not really, it's just some algebra, as I get it.
Yeah, and then the idea is that firstly, you can see that you have x minus 2 here, or 1 minus 1/2, so that if you have the adjunct who is exactly in the middle, so he will be indifferent in this term. So I mean, if the adjunct is in the middle, so his utility of joining aggregator depends only on the union of quality, because yeah, his distance to both agency is the same. And then we have this part about the quality on exact agency. So then if we have some preferences to different agencies, which means that x is not 1/2. Then the difference of quality affects our utility using aggregator. Is it clear?
So just to make it straight, like the guy who has quality x equal to 1/2 just doesn't care about quality of the agencies.
No, he cares, because initially in our, so what is left in his utility is still the union of quality. But
Okay.
since he is different between agencies, he doesn't care about where this quality is provided by whom, by which agency. So I don't care from which agency I receive the news of good quality, because I'm indifferent between agencies.
And if we assume another consumer who isn't indifferent between agencies, in this case, those measures of the topics, like the how to name this mu, like the broadness of topics of agency.
Quality.
Is it?
Yeah, this is quality of agency 2. Sorry, that's another color, right? So that's quality of agency 1, and this quality of agency 2.
Yeah. So it's the range of high quality news for agency I. Well,
Yes.
okay, got it. Okay. So if the consumer cares about agencies, like if he isn't different between them, he cares about the quality, the range of their quality news as well, right?
Once again.
Okay, if our consumer is not indifferent between agencies, he cares about the quality.
No, he cares about the quality, so that's, let me write it. So in total, answer is that utility of joining the aggregator is utility of your reading, the quality of total news available on the aggregator, and then this part which we got, right? So let me write it like that. So if we are on the interval 0, 1, and this is agency 1 and this is agency 2, and let's say they are somewhere here, so this is our agent X. So then this is negative, right? So then if the quality of the second aggregator is greater, then we have disutility from this part. Right? So if Q2 is greater than Q1, then we have disutility. But then if the quality of our most preferred agency Q1 is greater, then aggregator provide more news from agency 1, and they like to use aggregator more, because on aggregator we will have the news from the closest agency, which we like more, because to agency 2 is too far away. Do you see?
So in this case, yeah, I see that x minus 1/2 is less than 0, and I guess Q1 is greater than Q2. No.
No, it depends on the choice of agencies.
And this this consumer, he doesn't want to go to like second agency.
Yeah, because he's far away to agency 2. Yes, because here it will be transaction costs tau 1 minus x, which is greater than tau x. Okay.
Yes, but how does it correspond with the sign of the bracket of x minus 1/2? Like,
Because it's how you're far away from 1/2, right?
yeah, I understand this. I just like, okay, in this case, we have a minus, right?
Yes, minus means that because here the quality of second agency goes first, minus quality of agency 1. So that means if you are closer to 0 and you got minus in first bracket, then you don't like if the quality of agency 2 is higher, because then on aggregator you will face a lot of news from aggregator 2. Oh, sorry, from agency 2, which you don't like. So that you will prefer to have a quality news from agency 1, and then the second bracket will be negative as well. Yes, if the quality of first agency higher, and you will enjoy aggregator more.
Yeah, and if it's lower, I will enjoy aggregator less. Got it.
So it kind of, if you like agency 1 more than second, you would like to face on aggregator the news from agency 1 instead of agency 2. Okay, let's move to the last part with 3 steps. So the last point is about the Nash equilibrium without aggregator, so that we have only 2 players, 2 agencies. And since there is no aggregator, then we are talking about only vertical differentiation, because now we don't care how our news quality choice intersect, because intersection of yes, so that's how our I1 and I2 intersect depends only on quality of aggregator. Yeah, consumers cares only about the quality, total quality on your. So they don't care about the exact topic which you that you cover with high quality. So then now they don't think about the intersection and how they exactly pick the quality on the interval 0, 1. So we care only about the Q. So how much topics are covered with high quality. So then let's do the standard steps. We need to derive the indifferent consumer. So what we need to do to derive the indifferent consumer?
We need to equalize the utility gained from joining the first agency and the second agency.
Yes, this will be U bar plus Q1 minus tau x hat equal to U bar plus Q2 minus tau 1 minus x hat. So it's like in our standard linear city model we discussed. So that U bar goes, and we can see that so they have tau x hat 2 times minus tau equal to Q1 minus Q2. So that we can say that x hat is 1/2 plus Q1 minus Q2 divided by 2 tau. Yeah, it's the similar formula we get before. but before they had prices instead of queues, right? And then we are talking about the city model. There was difference between prices of platforms. And that's the position of indifferent. So then they need to derive the best response for the two media agencies. So what we need to do for that?
We should, I know, solve the system is late. Shouldn't we just like maximize the profit of each agency?
Exactly. So firstly, we know that consumers are distributed from 0 to 1, and there is some indifferent. So that those who are closer to agency 1, they join the agency 1. So that, and those who are to the right from this indifferent, they join to agency 2. So then we can say that alpha 1 is x hat, and alpha 2 is 1 minus x hat. And then we can move to the profit maximization problem. So you remember that profit of agency 1 was alpha 1, 1 plus delta q1.
Excuse me, what is alpha gain?
Alpha is the share of the market. So
Ah, okay.
how much agents join our news agency. And that was minus costs, which is CQ1 squared. So taking first order condition, we will receive alpha 1 delta minus 2 CQ1 equals to 0. And then they need to plug in alpha. Yeah, so they remember that this is x hat, which is equal 1/2 plus q1 minus q2 divided by 2 tau. So then,
Sorry.
yeah.
Why do we plug in the indifferent consumer?
What?
Why do we plug in the X? Well, the type of indifferent consumer into. Ah, yeah, I see. Because the first share is equal to it. Okay, sorry.
Yeah. So then we have delta over 2 plus delta q1 minus q2 2 tau equal to 2cq1. So let me multiply everything by 2 tau, so it will be tau delta plus delta q1 minus delta q2, and this equal to 4 tau cq1. So then I can rewrite it as everything behind q1 is 4 tau c minus delta q1 equals to tau delta minus delta q2. Looks like the truth. So, and then q1 as a function of q2 is tau delta minus delta q2 divided by 4 tau c minus delta. So that's about best response, right?
I guess for the second one, it will be just like the symmetric, right?
Exactly. So then you can check it by yourself at home. But so instead of alpha, you will have 1 minus x hat, but 1 minus x hat. So if you take 1 minus x hat, you will have, so let me write it here, right? It will be again 1/2, but then you can change the order here. Right? Because you need to put minus here, but then you can put it inside, and then index is just changed. So then the problem will be the same.
Could you please slide a bit higher for a couple of seconds? Thank you.
Okay.
Yes.
So
And-
what? Yeah.
And now, just as in any Nash equilibrium, we should just solve the system of best responses and get the optimal.
Yeah. So what you need to do is solve this system or plug one into another. But what you can guess?
It will be symmetric.
Yes, so equations are the same, exactly. The parameters are the same. So probably, so you can guess that Q1 equals to Q2 equals to some Q star. And then we can just plug it into one equation, and it will be that Q equals to, what was the tau delta minus delta Q star, and divided by 4 tau C minus Q, or minus delta. So what it will be, so it will be 4 tau C Q star minus delta Q star equals 4 delta minus delta Q star. So we can cross this. And then, so divided by 4, so that Q star equals to delta over tau C. Yeah.
Do we?
Any questions?
Not about calculations. They are obvious and like traditional
Hopefully.
Nash equilibrium problem. But about the interpretation, do we interpret it somehow?
So, well, it's actually obvious that if you have symmetric problem, then you will receive symmetric answer without aggregator, actually. So with aggregator, the problem is much more complicated. And then, yeah, I will check if I will ask you something about that during the final to think a bit advance. Maybe. And here is just so like everything depends on the parameters so that you can.
I mean, we don't really interpret that it depends like positively from delta and negatively from tau c.
So the delta is your marginal return from quality. It's actually obvious that you want if it's greater than you gain more from quality, so you want to increase it. So tau is the distance and c is cost, so you have negative dependence on costs. That's obvious. Then what you have tau here is that how. So the larger tau means that less. So for the agent who is in some distance, for him it's more costly to join your agency. Do you see? So that if you save the distance, fix the distance the same, and increase tau, the cost of joining the agency is increasing, right? Because you just increase the costs per distance.
Yeah.
So that's mean that if you have lower tau, then it's kind of you can attract more users and gain more profit. But yeah, it's intuition, but not the correct answer, because then you have competition between two platforms, right?
Could you please repeat the last idea?
So then, if you have agency, right, one, and let's say that, yeah, normally you will have something like the utility of joining the agency is like that. So this is X. So then you can find some indifferent who is indifferent between joining the agency or not. Yes, and if you increase tau, yes, so if you increase tau, then you will move this indifferent agency to another point, right? Because your costs of joining the agency increase due to higher transfer costs, right?
Yeah.
So, but yeah, it's intuition. But then you have the competition between two agencies because, yeah, here is the second agency. And what is actually, yeah, so like how they want to proceed is, yeah, put the cost such that they minimize the costs but still divide the audience. But I guess that's the question for final, so I will not answer this question right now.
Okay.
So then that's it for today. I will upload the notes and yeah, and set up as well to our folder. When so if anyone have questions about the course or about CFGI, you can ask me. If not, you can just join, and we will see you on final.
I have a question related to our home assignment.
Okay.
Did I guess correctly that intensity of network effects is less than 1? Right?
Wow.
I guess it's logical because otherwise it's like the
Yeah, I think
spiral.
so. I think so, but I don't really involved in this problem right now, so I have to So it's problem set.
It's like the first problem. It's the parameter of the utility. There is like no condition for it, but if it's more than one, it's something strange. It's like a financial pyramid or something.
You mean V, parameter V?
Yeah.
I guess you can assume so it was something in the lecture, so it's between 0 and 1, I guess.
Yeah, okay. Because otherwise it's something strange. So it's like I gain more than one point of utility for each user. So
if you went to question 2 and go to hint D, then there will be discussed.
I just needed this knowledge in the first one, so yeah, okay, got it.
So I remember there was a question about parameters, so that probably you will be asked about in this case, in which cases what happens. So.
Yeah, okay, got it. Okay, that's all for my answers for now, I guess. Anything else I'm figuring out? I hope so, at least.
Yeah, you can write me.
Yeah, okay. In this case, thank you for your course. It was interesting.
I hope so, and good luck on final.
Thank you.
Final grade.
Thank you. Goodbye.
Bye.